Hi guys. Sorry I've been away for quite a while. It's been a pretty darn busy spring and summer this year, and I'm finally getting a little bit of quiet time now, although I got some other stuff going on too at this point too. That well, when that gets done, I'll show you what it was all about. But anyway, getting right to what we're going to be talking about today. This is my single core, Hickok signal core I177B tube tester. I did some videos on it quite a long time ago, but never actually ever got around showing the finished. She didn't work right when I first got her. A little bit of brief history on it. I bought it, got it real cheap because it had been in a fire, or it had caught fire. And I'll get to that in a minute why. And someone had tried to repair it and ended up not having it, still not working right. And basically what it was doing, well, at first was doing nothing. Then after I got it where it would actually try to do something, then the needle, when you'd hit amplify test down here, would go the opposite direction. Just only on amplifier tubes. If you did a rectifier, testing rectifiers, diode tubes, everything worked fine. And line test worked fine as well, but only on amplify, then it would go to 0. Now I've got a tube in here to show that it is working. Go through the shorts, and it's a weak tube, and it's getting weaker as it goes on, but the needle is going in the right direction. So, what was wrong with it? Well, to start off with, one of the things that was wrong, and I wanted to bring the schematic in here. Now this is a scan of the factory original schematic that's in the bottom below the chassis. All these come with a schematic that's been they put in there and riveted in, and here's where the firewood. That's why this is all discolored. It was basically this switch here that caught fire. So, first problem, and that switch A, which is down the corner, this guy here, is this switch right here. If it'll set. Let me get you in a little closer here. And bear with me. I'll make some adjustments here. Focus. Alright, there we go. Now, it's a 4-section switch, even though it shows multiple switches. This is the front and back of section 1. This is section 1, front and rear. And then the other 4 sections only got, they only show the rear because that's the only places there's any contacts. Now, all the switches are set in position 1 being shown, and they're being shown from the back side. So it would be as if you pulled the chassis out, take it out and flip it over. So this would be what you'd see at the very top, the first section here. This switch had been taken apart to clean it by someone. What they ended up doing, though, when they put it back together, they mixed up two sections of it. Section 2 and Section 4. They had switched them. In other words, they put Section 2 in the position of Section 4 and Section 4 in the position of Section 2. Now, they appear to be, if you look at my little color coding here, that the switches appear to look the same, but they're not quite. The little center part right here on all these switches is what rotates. These outer points here that's got the arrows, those are the contacts. If you look at this one and this one, they appear to be the same, but in different positions. Again, the switch is supposed to be in position 1 on the schematic. So this would be how they would be setting if you flipped that switch in position 1 and looked at both of these sections. You notice that the rotary part is one click off difference. This one here is right at this point here, the edge of it. This one here, that edge, is up at the next point. What that did was, when you was to test any tubes and you go through the chart, they tell you where to set the switch would not be set in the right place by having these switched around. And basically, they basically connect up the plate circuit, and if there's a screen grid, the screen grid circuit. So with them turned around, the tube was not getting no plate voltage, nor was it getting any screen voltage, thus no current through the tube. Thus, when you test it, it read 0. Nothing was going on. So I went ahead, and once I found that, I took the switch back apart and switch these back around. Once I did that, that's when the meter would start reading backwards. And kind of zoom out here a little bit. The needle would go this way instead of upscale. So I had to go look for that. Now basically what I did, start off with, and the way I found there was a problem with the switch, was I set all the switches, switch A and B, basically set the short switch on testing the tube, so it's not checking shorts anymore. And I set everything up, or at least the switches up and everything, to check a 6V6. With that, I knew from the tube socket, and from the pin layout, which pin was plate, which pin was control grid, screen grid, cathode. And then I could take and measure continuity from those pins, each individual pin, to where it sources its voltage. Now the plate gets its voltage from the 83 tube, actually from Z right here. Hopefully, let me rotate down just a little bit here. Right here is where the plate gets its voltage. Now this goes through the amplify switch, so you have to push it when you're doing this. The screen grid gets its voltage from K, the 5Y3, and it also has to have the amplify button pushed to get any continuity. The cathode actually pulls off right at this point here. Doesn't matter, you don't have to push the amplify button to measure it. And then your grid actually comes off of N. It comes through here, goes through gas 2 switch, and which is normally closed. And you don't have to push the amplify button for that. So I did a continuity check. That's when I found that I did not have no continuity on plate or screen. So then I traced it out, came to this switch being wrong. Fixed that. Now, to understand a little bit about once I fixed that, why the meter was reading backwards on amplify, you have to kind of understand how the tube tester actually works. And it's actually a simple circuit. But we're going to bring another schematic up here in a minute. But I want to turn down to the main portion of this thing. All the rest of this, up here you just got your sockets, and it's showing, all the wiring to them. These 2 switches here are connecting up all your main elements to your tube, to the tube tester. This bottom row of switches, this is just your short switch, and this switch over here, right here, is just your filament switch. Set your different filament voltages. So the actual tube tester boils down to this section right here. Now the 5Y3's job, its only job, or two jobs basically, is to supply our negative voltage for bias, and to supply, if it has a screen grid, any tube that, a tetrode, a beam power tube, such as a lot of audio tubes, pentode, any number of those tubes that would have a screen grid, it supplies the screen grid voltage. That's the 2 things it does. The 83 tube is used to actually supply the plate voltage, and thus has the meter in its return path, or in the cathode circuit, and the return path back for the 83, to measure the tube current, or the plate current. And remember, we're measuring GM. Even if we're setting on English, we're still doing that, which is mutual conductance or transconductance, which is a ratio of change in plate current compared or to the change in grid voltage. So as the grid voltage changes, it changes the current going through the tube, thus changing the plate current. And that's what we're measuring. So the meter is actually measuring the plate current, or its change actually. In order to measure change, I have to have a balanced circuit or a bridge circuit of some sort. I got to be able to measure the change in it as it changes, not so much a continuous amount. To help understand that circuit a little better, I've got another little schematic that's a simplified drawing. Now this is actually for a TV3B. It's not actually for this tube tester, for the I177, because in the manual, the I177 is drawn wrong. When they draw the simplified, they got the cathode hooked up wrong. The only difference between this tube tester and the I177 is it's a little newer, and it was making use of being able to test some newer miniature tubes that the screen voltage on those tubes, some of them was actually less. The I177 is set at 130 volts for screen. some of the miniature tubes, newer miniature tubes, newer than what the I177 was designed for, the screen voltage is less, or needs to be less. So the only difference between this tube tester and this one boils down to this connection here and this switch. This changes between the high or low screen voltages. So basically the high would be 130 volts for only the screen grid. So don't worry about that. Basically, and they changed the size of the resistor here a little bit. In the I177, this would be a 6K instead of 8.5. But otherwise, the tube testers are identical. The main thing I want to look at is right up here. Now, one of the big things about how this tube tester works is, since I'm measuring GM, which I have a change, I have to have a change in my grid voltage, control grid voltage, I have to be able to change that. So the way they do that is there's a winding here. It's showed as section number 3, and it in the main schematic, it's this winding here. It's a 5-volt AC. There's no rectification of it because I want it AC so that can change the screen. It's tied into here. This is the R pot, or your bias pot. This is just the bias for the individual different tubes. You set that. Your tube chart tells you where to set it at on the tester. And then this supplies in a 5-volt AC signal, and that allows for the grid to change. That has to be in sync with these two windings here. Each one of these windings goes to the 83 plates. So at one point in time, if we just pick a point in time, we can say that at one point, half cycle of our 60 cycle AC, this will conduct. This will be positive. Will conduct through the tube, feed through here, go through our tube under test, through our cathode circuit, make a return path back to here, and it wants to come back here. Now, it's going to split because I got a meter in parallel. This is your L pot here, and that you adjust, and it also has a setting for GM if you're wanting to test GM. It is a shunt across the meter. And so as the current comes up here and goes up, actually at this point, part of it can go this way, part of it's going to go around, go through the meter, and come back around, and they'll combine and finish the circuit. That's going to cause that meter to move a certain way, in a direction. Say, in this case, upscale a certain amount. Now the next half cycle, this side conducts. So we'll have current going through the 83, going this way, through the tube, back around. But in this case, the current's going to split. Part of it's going to go this way, part of it's going to go this way, opposite through the meter, and back around, and recombined, and finish out our circuit. That will cause the needle to go the opposite direction. The difference between those two will be averaged out. In other words, added together and divided by 2, creating a difference, and that will push the meter upscale to your reading of what you're going to read on that tube. While all this is going on, this point down here is also fluctuating. One half cycle, this side's positive. The other half cycle, this side's positive. So it's AC, it's flipping back and forth. It is changing the grid voltage. Now the grid will always stay negative. That's a given. But when this is more positive, when this is actually positive, feeding positive to that grid, it makes it much less negative, so more current flows through the tube. And if everything's set up right and calibrated correctly, the needle goes upscale a certain amount. Then, the next half cycle, this actually becomes negative, feeding more negative voltage to the grid, which makes it quite a bit more negative, a serious drop in current going through the tube, which then the needle will try to move a certain amount the other direction, in the opposite direction now. Being they're imbalanced, in other words, when this is positive, the grid is less negative, higher current. There's a lot more current, a lot more movement of the needle, as opposed to the other half cycle, when the grid's a lot more negative, then this needle reads upscale, and if it's a good tube, will read good, or if you got it on GM, will read the proper micromoles. The problem is why the needle was going the wrong direction wasn't because the meter was hooked in wrong. This tester, he had tore it quite a bit apart. He actually had the transformer out, which meant it was disconnected and everything. So all these winding connections was disconnected. All this was taken apart. He's probably looking for a bad wire, my guess is. In any case, everything was disconnected except for the filaments. He left those connected, but they were just hooked to this switch, which can come out with the transformer. But all these guys were disconnected. Well, when he hooked it back together and put it back together, he followed the schematic in the base of the unit. Turns out the schematic's wrong. This P and Q, this 5 volt AC is drawn, connected wrong. P should not go to this point here. These are ganged together pots. That's your L pot. That's this guy right here. They're stacked, and this little connection between here at one side, you got your 3 connections on each pot. At one end, there's a wire that goes between the two and connects them. At that point is where coming this way is your cathode, and coming this way showing P. No, Q is supposed to be connected there. P should go to the wiper on R pod. This guy. Oh, you can't see it. R pod here. The schematic is wrong. And that's what he followed. And what that does, this has to all stay in sync. When each one of these is like, when we're looking like this one's going positive, and this one's would be going positive and positive, you know, on 1/2 cycle, this all's got to be in sync. If it's not, the grid will get the wrong voltage at the wrong time for the meter to read upscale. So instead, everything, the difference reads it downscale or past 0. Now, I looked up many of these schematics. There's plenty of places on the internet. People has taken pictures of theirs and their I177s. They've even took pictures of the units. And I've looked, every last one of them is wrong. So I don't know why, but they are wrong. So if you ever get one of these, and if for whatever reasons a lot of this wiring is either disconnected or cut or something, be mindful that the schematic's wrong. Flip these two when you go rewiring it. Everything else seems to be fine in the schematic. But that was what was actually wrong with this unit. Now, why did it catch fire? Well, let me back out here a little bit. And, okay. When you're testing a tube, on any tube tester, once you get the tube, allow it to heat up for probably 15 minutes. It's always good to do that. Before you ever hit whatever button it is to test the tube. Amplify on this, some of them just test, whatever. Always, always, always check shorts. You know, on this you flip the switch through. Some tube testers have got levers that you flip. Some's got push buttons. Whatever the means is, always check for shorts before you ever hit the test. If that light comes on when it shouldn't, in other words, showing, now it can flash, that's normal. But if it comes on solid, and there's nothing in the tube manual, in the tube chart that says, okay, because some tubes, it'll tell you that it'll show a short at a certain, certain position. But if it doesn't have that, if this light comes on, you've got a shorted tube. Now, most of the times, it's just a little leakage. These are very, very sensitive lights. But, you know, it doesn't change indication if it's a dead short or not. It could be a dead short. And if you test that tube with a dead short in it, ignoring your shorts indicator, it'll damage your tube tester, I guarantee it. This is why this thing caught fire. Remember, A and B are connecting up all the connections to the tubes, pins. In other words, all that current is going through these switches that goes through that tube. If I have a short, dead short, that's going to be a lot of current going through there. And it'll overheat and catch fire. And that's what happened. I'm about out of time on this video, so I'm going to cut this off right now. Sorry I've been gone. I'm fine. Everything's good. I hope you understand what I told here, and be looking forward to another video sometime soon. Thank you for watching.